Hi everyone, I am Waybase SB, Junior College Teacher, RBNB College, Sri Rampur. In the previous lecture, we have taken some examples from exercise 5.4. Now in today's lecture, we are going to see some more examples from the same exercise. So let's see the first question. Prove that two into a bar minus b bar cross 2 into a bar plus b bar is equal to 8 into a bar cross b bar. Now in our textbook, here on right hand side, here 4 is given. I think it is print mistake. So correct it as 8 into a bar cross b bar. Okay. Now to prove this one, first consider left hand side, LHS. Left hand side. What is left hand side? 2 into a bar minus b bar cross 2 into a bar plus b bar. Again it is equal to. See, we have seen one property that m into a bar, its cross with n into b bar is equal to mn into a bar cross b bar. Now here we have to use this property. So which is equal to m into n means 2 into 2, that is 4 into a bar minus b bar, its cross with a bar plus b bar. Again it is equal to, now 4 into in bracket, now distribute this cross product. So a bar cross a bar plus b bar minus b bar cross a bar plus b bar. A bar plus b bar. Again it is equal to 4 in bracket. Now by left distributive property, first distribute this first term, that is a bar cross a bar plus a bar cross b bar minus b bar cross a bar minus plus minus b bar cross b bar. So again it is equal to 4 in bracket. See, a bar cross a bar is 0 vector. So it is 0 vector plus a bar cross b bar minus b bar cross a bar minus b bar cross b bar is also 0 vector. Or you may write the reason here, a bar cross a bar is equal to 0 vector. So again it is equal to 4 in bracket a bar cross b bar minus b bar cross a bar. Again it is equal to 4 in bracket. See, we know that cross product is not commutative. Cross product is anti-commutative. Vector product is anti-commutative. It means that we have a bar cross b bar is equal to minus b bar cross a bar, or b bar cross a bar is equal to minus a bar cross b bar. Using this property, this minus b bar cross a bar is a bar cross b bar. So it is a bar cross b bar minus b bar cross a bar is a bar cross b bar plus a bar cross b bar. Or you may write the reason also here, that is, since a bar cross b bar is equal to minus b bar cross a bar. Again it is equal to 4 in bracket a bar cross b bar. See, a bar cross b bar plus a bar cross b bar, it is 2 times a bar cross b bar, 2 times a bar cross b bar. So now 4 into 2 become 8 times a bar cross b bar, and that is what we want to show, and that is, this is nothing but right hand side. So therefore 2 into a bar minus b bar cross 2 into a bar plus b bar is equal to 8 times a bar cross b bar, and hence proved. So this is first question in which we have proved 2 into a bar minus b bar cross 2 into a bar plus b bar is equal to 8 times a bar cross b bar. Now the next question, find the area of parallelogram. Find the area of parallelogram whose adjacent sides are the vectors a bar is equal to 2i cap minus 2j cap plus k cap, and b bar is equal to I cap minus 3j cap minus 3k cap. In this question, the two adjacent sides of a parallelogram are given, means these are two vectors a bar and b bar, and here we have to find out the area of parallelogram. So write first, let a bar and b bar are the two adjacent, or these are two vectors adjacent sides of a parallelogram. What is a bar? 2i cap minus 2j cap plus k cap, and b bar is also given, it is equal to I cap minus 3j cap minus 3k cap. These are the two adjacent sides of a parallelogram. It means if this is the parallelogram, then along these two sides, this is a bar and this vector is b bar. And we know that the area of this parallelogram is nothing but the magnitude of a vector a bar cross b bar. So therefore the area of parallelogram is equal to magnitude of vector a bar cross b bar. First, here we have to find out a bar cross b bar and then its magnitude. Now, a bar cross b bar is equal to the determinant I cap, j cap, k cap. Now, first row is the coefficients of I, j, k in a bar, and that is 2. Second row is the coefficients of I, j, k in a bar. And first row is common everywhere, a bar cross I cap, j cap, k cap. So 2 minus 2, 1. That is second row. And now third row is the coefficients of I, j, k in vector b. And that is 1 minus 3 minus 3. It is equal to. And this is 3 by 3 determinant, and we know that how to solve 3 by 3 determinant. So first term, I cap in bracket. Now I cap lies in first row and first column. So leave first row and first column and take the determinant of remaining 4 elements. And that is 2 by 2 determinant. And so its value is minus 2 into 3, minus 6. And minus 3 into 1, minus 3. And minus of minus 3 become plus 3. minus j cap minus j cap. Just 1 minute. 1 minus 3, yes, here this is minus 3. 1 minus 3 minus 3, so it becomes plus 6. 6 plus 3. Minus j cap in bracket. Now j cap lies in first row and second column. So leave first row and second column. The remaining 4 elements are these. And take the determinant of these 4 elements. That is 2 into minus 3 minus 6. 2 into minus 3 minus 6 minus 1 into 1 1 plus k cap plus k cap. Now k cap lies in first row and third column. So leave first row and third column. Take the determinant of remaining 4 elements. 2 minus 2, 1 minus 3. And it is 2 into minus 3 minus 6 minus minus 2 into 1 minus 2 minus of minus 2 plus 2. So it is k cap in bracket minus 6 and minus 2 into 1 minus of minus become plus 2. So therefore A bar cross B bar is equal to, see, I cap into 6 plus 3 9, that is I cap into 9 minus j cap into in bracket minus 6 minus 1 minus 7 plus k cap in bracket minus 6 plus 2 minus 4. So finally it is 9 I cap minus minus become plus 7 j cap plus, and this minus become minus 4 k cap. Now this is A bar cross B bar. Magnitude of A bar cross B bar, it is equal to square root of 9 square plus 7 square minus plus minus 4 square, and so it is equal to square root of 9 square 81 plus 7 square 49 and minus 4 square 16. It is equal to square root of, so 81 plus 49 130 and 130 plus 16 146. 146. So A bar cross B bar is equal to, magnitude of A bar cross B bar is equal to square root of 146. And the last, you know that the area of parallelogram is magnitude of A bar cross B bar. So therefore area of parallelogram is equal to magnitude of vector A bar cross B bar, and it is equal to, see, magnitude of vector A bar cross B bar is square root of 146. It is square root of 146 square unit. So this is the area of parallelogram whose adjacent sides are A bar and B bar. So next question, third question. Find the area of parallelogram. Find the area of parallelogram whose diagonals are determined by the vectors. Whose diagonals are determined by the vectors. A bar is equal to 3 I cap minus j cap minus 2 k cap and B bar is equal to I cap minus I cap plus 3j cap minus 3k cap. See, I bar is 3I cap minus j cap minus 2k cap, and B bar is minus I cap plus 3j cap minus 3k cap. Okay, let's see here. Now in this example, the vectors along the two adjacent sides of a parallelogram are not given. Here the vectors along the two diagonals are given. So see, if this is the parallelogram, and these are the two diagonals. So A bar and B bar, if this along this diagonal, this is the vector A bar, and along this diagonal, this is the vector B bar. So now A bar and B bar are given. If this is A, B, C, D, this A, B, C, D is a parallelogram. Now we know that if A bar and B bar are the vectors along the two adjacent sides, then the area of this parallelogram is A bar cross B, magnitude of A bar cross B bar. Now if the vectors along the two diagonals are given, then the area of this parallelogram is 1 by 2 into magnitude of A bar cross B bar. 1 by 2 into magnitude of A bar cross B bar. This is the formula. And vector area means 1 by 2 into A bar cross B bar. So if you want to take the area, so take the magnitude here, and if you want to find out vector area, so don't take the magnitude, only keep it as it is a vector A bar cross B bar. So let's see the solution for this question. Let A bar is equal to 3I cap minus j cap minus 2k cap, and B bar is equal to minus I cap plus 3j cap minus 3k cap are vectors along the diagonals of a parallelogram and as these are the vectors along the diagonal of a parallelogram, so therefore the area of parallelogram is equal to 1 by 2 into magnitude of A bar cross B bar. So let's find A bar cross B bar. So now A bar cross B bar is equal to, as I have told you in the previous example, if you want to find out A bar cross B bar by using the formula in the form of determinant, so first row is I cap, J cap, K cap. Now second row is the elements or is the coefficients of I, J, K in A bar. Now see, A bar is here. The coefficients of I, J, K are 3, minus 1, minus 2. So second row is 3, minus 1, minus 2. Now third row is the coefficients of I, J, K in vector B, and these are minus 1, 3, minus 3. So it is equal to, now this is 3 by 3 determinant, this is 3 by 3 determinant, and we know that how to solve it. So take first element I cap in bracket. Now this I cap lies in first row and first column. First row and first column. So leave first row and first column. Delete first row and first column. And take the determinant of remaining 4 elements. That is minus 3 into minus 1, 3. Minus 3 into minus 2, minus 6. Minus. Second element minus. Minus j cap in bracket. Now j cap lies in first row and second column. So leave first row and second column and take the determinant of remaining 4 elements, that is 3 into minus 3 minus 9. 3 into minus, just 1 minute, leave first row and second column. 3 into minus 3 minus 9, okay, and then minus 1 into minus 2 plus 2, so it is minus 2. That is 3 into minus 3 minus 9 and minus 1 into minus 2 plus 2 आणि फॉर्म्युल्यामध्ये असणारा minus, so minus 9 minus 2. Third element is plus k cap in bracket. Now this k cap lies in first row and third column, so leave first row and third column and take the determinant of remaining 4 elements, that is 3 into 3 9 minus 1 into 1 plus 1. So it is 9 minus 1. So therefore it is equal to 3 minus of minus become plus, 3 plus 6, that is 9. So it is 9 I cap. Minus 9 minus 2 minus 11. Minus 11 minus become plus 11 j cap. And 9 minus 1 8 plus 8 k cap. So this is your A bar cross B bar. So take the determinant of A bar cross B bar. Determinant of, see, first I will write it here, A bar cross B bar. It is equal to 9 I cap plus 11 j cap plus 8 into k cap. So magnitude of A bar cross B bar is equal to square root of 9 square plus 11 square plus 8 square, and it is equal to 9 square, that is square root of 9 square 81 plus 11 square 121 plus 8 square, that is 64. Again it is equal to. Now take the addition of these two. So 4 plus 1 5, 5 plus 1 6, square root of 6, then 6 plus 2 8, 8 plus 8 16, 6, and 1 plus 1 2, so 266. So magnitude of A bar cross B bar is 266. So therefore, and we know that the area of parallelogram is 1 by 2 into magnitude of vector A bar cross B bar. So therefore the area of parallelogram is equal to 1 by 2 into magnitude of vector A bar cross B bar, and it is equal to 1 by 2 into square root of 266, or that can be written as square root of 266 divided by 2 square units. So this is the area of parallelogram whose diagonals are A bar and B bar. So this is the complete solution for this question. Now let's see next. Find the direction ratios of a vector. Find the direction ratios of a vector perpendicular to the two lines, perpendicular to the two lines whose direction ratios are perpendicular to the two lines whose direction ratios are -2 1 -1 and -3 -4 1, -3 -4 1. So see, Here we have the direction ratios of two lines and we want to find out the direction ratio of a vector which is perpendicular to these two lines. Suppose if these are two lines whose direction ratios are -2, 1, -1 and -3, -4, 1. So the vectors along these two lines are -2 I cap plus j cap minus k cap and -3 I cap minus 4 j cap plus k cap. Because if we have the direction ratios of a line, then we know that the vector along that line, we know that if ABC, these are the direction ratios of any line, then the vector along that line is A into I cap plus B into j cap plus C into k cap. So here direction ratios of two lines are given. It means that the vectors along these two lines are known. So first we write, let A bar and B bar be the vectors along the lines with DRS, means direction ratios, -2, 1, -1 and -3, -4, 1. So therefore your A bar is -2 I cap plus j cap minus k cap and B bar is equal to -3 I cap minus 4 j cap plus k cap. Suppose if this is A bar and this is B bar. So now in this problem we have to find out the direction ratios of a vector which is perpendicular to these two lines. And we know that the vector which is perpendicular to these two lines means vector which is perpendicular to A bar and B bar, and we know that that is A bar cross B bar, that is A bar cross B bar. So first we find the vector which is perpendicular to these two lines, means the vector which is perpendicular to A bar and B bar. So therefore the vector A bar cross B bar is perpendicular to A bar and B bar. It means that A bar cross B bar is perpendicular to the two lines, because along these two lines we have the two vectors A bar and B bar. So now find out A bar and A bar cross B bar. Now A bar cross B bar is equal to, as usual, first row is I cap, j cap, k cap. Second row is the coefficients of ijk in A bar, and third row is the coefficients of ijk in B bar, and that is -2, 1, -1, -2, 1, -1, -3, -4 and 1, and it is equal to, solve this 3 by 3 determinant. So it is I cap in bracket. Now I cap lies in first row and first column, so leave first row and first column, that is 1 into 1, 1, minus -4 into -1 plus 4, that is 1 minus 4, minus j cap in bracket. Now leave first row and second column, because j cap lies in first row and second column, leave first row and second column. So remaining 4 elements are these. Take the determinant of this, -2 into 1, -2, -2 into 1, -2, minus -3 into -1 plus 3, so it is -2 -3 plus k cap in bracket. Now k cap lies in first row and third column, so leave first row and third column, that is these 4 elements, -2, 1, -3, -4, and take the determinant of these 4 elements, and that is 2 by 2 determinant, and so its value is -2 into -4 plus 8 minus minus 3 into 1 minus 3. So minus of minus 3 become plus 3. So A bar cross B bar is equal to, it is equal to I cap into minus 3, 1 minus 4 minus 3, minus J cap in bracket minus 5 plus K cap in bracket 8 plus 3 become 11. So your I cap that is equal to, see, minus 3 I cap minus and this minus become plus 5 J cap and 11 plus 11 K cap. Now this is A bar cross B bar. So A bar cross B bar is equal to minus 3 I cap plus 5 J cap plus 11 K cap. Now this is the vector which is perpendicular to the two vectors A bar and B bar. So A bar cross B bar is the vector perpendicular to the two lines. So it is minus 3 into I cap plus 5 into J cap plus 11 into K cap. So the direction ratios of this vector are minus 3, 5 and 11. So therefore the direction ratios of a vector perpendicular to the given lines are minus 3, 5, 11. So today we stop it here. Thank you.